All right, so we kick off our second office hours for this project. Before we start, wanted to let you all know that I've gotten a lot of messages from people saying that visualizing the trees, the string, something about the string IO or something about like the scikit-learn 6 isn't working. I'm going to look into that for you all, and then I'll post something in the channel if I find. Hopefully I'll find something, because it's weird because it works on my computer. It says that you need an older version, but I don't have an older version. So I'll keep looking into that. Also, I think some people are running into issues with installing Smote from Imbalanced Learn. So I have a line of code for that I need to look for, and I'll send out the channel as well, just in case anyone else is having issues with that. All right. So let's take a look at some of these questions that we've gotten since yesterday. So first question I have here, is it possible to just scale continuous variables and leave the categorical variables as 0 and 1? Definitely yes. It makes sense to only scale your continuous variables, categorical variables being 0 and 1 makes sense. This part where your zeros and ones have become weird numbers, it surprises me, because usually if your scaling sees those numbers, means that your categorical variables, if in your 0, 1 column, you have other numbers that are skewing it. Because if you are doing for example, if you're doing a min-max scalar, if you only have zeros and ones, your result after the scalar should still be either 0 and 1 or -1 and 1. So do check to see if you have non-0, 1 variables, if that's happening. And then, yeah, for this, it would be that. I can also imagine that for if you're doing something like a standard scalar where it's normalizing, again, check for different values. I have a feeling this might be from using the standard scalar, but in the standard scalar, zeros and ones, because you only have zeros and ones. Oh, okay. I can see from the standard scalar that like if you have like if you have more ones than zeros, your mean will be off center, if that makes sense. So yeah, that could be why. If you're using a standard scalar on zeros and ones, your means and your standard deviations will be different. So like since your zeros and ones are like -0.56 and +1.76, your mean would be like the midpoint between those, and then it's just trying to do that. And if it's strictly just these two values, in your modeling, it actually should be fine. It shouldn't affect anything as long as you just have these two distinct values. That shouldn't affect most models. I think off the top of my head, I would say that it shouldn't affect your results in any of your models as long as you have these two distinct values. You're fine. But yeah, you're also definitely okay to just leave the categorical variables as is. Questions about any of that? Cool. One thing that kind of related to this, I know Melody, we were talking about this yesterday or this morning, I forget when, but if you have a categorical variable and then you do smote on your categorical variable, it will likely give you a bunch of random numbers between 0 and 1, just because the way smote works, it's creating additional data in the domain of your existing data. So that means if you have a feature that's binary 0 and 1, Smote will see that it's okay to create synthetic data between 0 and 1. So several ways you can get around it. First, you can convert your 0, 1 columns into I think you can do it as type category in pandas, or convert them to strings and objects. And I believe Smote won't do that, but then you would have to look into turning them into integers afterwards, or you can just reverse the order of your operations. You can do Smote first and then do your one-hot encoding. So up to you how you want to deal with that, but that is something that's worth looking out for. Although I will say, since it's just SMOTE data, having it be synthetic, it won't harm your model so much if your binary variables have, have synthetic data that is between 0 and 1. Questions about that? All right. Well, let's see. I saw another question here. Are there important differences for multi-class problems versus binary, especially related to metrics and interpreting your results? So the main difference in doing these two, doing multi-class versus binary, is going to be in evaluating and in your metrics. Because, as you all know, running the models for multi-class or binary is pretty much exactly the same. The main thing in your metrics, and I do recommend that for people doing the multi-class classification problems, to actually print out the classification report. So let me pull up that one. Classification report. And classification report looks like this. And this is for a multi-class issue. You have your precision and recall and F1 for each of your classes. So this is better for multi-class, in my opinion, because with your binary, we were looking at literally just like positives and negatives. But in a multi-class problem, what is considered positive, what is considered negative? So that's why the classification report comes in handy, because for each class, like for example, here we have 0, 1, and 2. These numbers are considering 0 to be true and 1 and 2 to be your false. And so it's kind of like a 1 versus all precision and recall, and therefore F1 score that's being computed. So through the classification report, you can get a sense of which class is being predicted better. And I usually like to look at recall for that, to see like out of all of the ones that are supposed to be 0, how many were actually predicted 0. And here you can see like all of the points were correctly predicted. Here you can see that none of the class 1s were predicted as class 1s, and 67% here. So I do think that for a multi-class problem, the metrics are where the main differences are. And in the multi-class problem, the classification report will be more helpful because it just has all the numbers there for you. And these numbers will correspond to your confusion matrix. So let me see if there's a confusion matrix here. Let's just look for one confusion matrix. Let's see. Oh, nice. I didn't know that there was a multi-label confusion matrix. That's cool. Oh, multi-label is different from multi-class. Just in case anyone's interested, multi-label is, let's say you have, each data point can have multiple labels. That's a problem we actually don't deal with in this course, but yeah, just in case that problem comes up, there's a difference between multi-label and multi-class. Here we go. So here with this multi-class confusion matrix, you can see specifically what was predicted incorrectly and what it should have been predicted as. And again, these numbers will, if you do like the positive, negative, 1 versus all for each class, those numbers will correspond to the classification report numbers.
So is there an overall metric? So if I'm like comparing models, for example, I mean, maybe certain models are going to do better at predicting certain classes versus others.
Yeah.
So how do you know which model for like a multi-class problem would be considered a better model, I guess?
So I would say it's really context dependent. So for example, if you have a multi-class problem, again, you would have your, let me pull up the classification report again. From the classification report, let's say let's say you have a minority class that like is what you want to maximize. So let's say in this scenario, just as an example, let's just say like class 0 predicting pretty well, class 2 is also predicting pretty well, but class 1 is not. You can actually get as granular as comparing your models based on like the recall for class 1. So it just depends on like how your baseline model, I mean, you can use your baseline model as something to like gauge, or really just like looking over all the models that you run, you can pick something to gauge how you want to score your model in your own way. So it can be a combination of like, maybe I want to like maybe class 1 is the one that I cannot have any false positives for. Then you'll look for that. Another thing is these averages in the classification report. So these are the macro and weighted averages of precision here in this
Okay.
column and recall here in this column. So if you want to look at overall precision and recall, you can look at these numbers. And these are just
Okay.
different kinds of averages.
And then the accuracy too is just the overall accuracy of your model.
That's right. So accuracy, because accuracy is really just computed by like correctly classified over everything else. There's accuracy doesn't exist for each specific class, but as a model as a whole.
Okay, so a combination of like contextual versus maybe some of the weighted average scores or something like that.
And it's up to you and also the context that you've set up in your problem to decide which ones you want to look at. It can be a combination, it can be just one. And it's just really context dependent.
Okay, cool.
All right, after this, I'll type up like a short spiel of that in here. I don't want to do this right now. Let's see, did I miss anything? I don't think there was anything above here. Oh, by the way, the model summary sheet is now linked over here. So feel free to just look through that. All the documentation is linked here, and everything that I think is important is in here. Also, like through 101, some of you have been asking really good questions, and I have been adding on here if there's something that I feel like I missed out. Something else, because yesterday I did talk about thinking of doing PCA. I actually just linked one of my old study group videos that I did on PCA a few months ago. It's not a long video. It's, I think, not like 20 something minutes long. So if you're thinking of doing PCA, and again, PCA is something to do if you have a lot of columns, you might consider looking at this. So I'll do the full study group for PCA when phase 4 starts, just so I'm not like adding any more onto all the stuff that we've talked about this phase. But for anyone who wants to consider PCA, that is there. Cool. Any other questions? I had something in my head, but I don't know if any of you have any questions. I like forgot what I was going to talk about for a bit. So if anyone has any questions, feel free to shoot.
I have a question about visualization of categorical data. Like my data set has, lots of categorical like text values, and I don't want to convert those yet to dummies because then it'll just be zeros and ones, and that's not very useful in visualization. So
yeah,
how best to deal with that if I wanted to visualize?
Yeah, I think if you have like, for example, a data set that has a column with a lot of different values, I personally like to use stacks bar charts. So for example, and this will be in your EDA phase if you want to see that there's a distinct difference in the way your categorical variables are spread out amongst your class. So let's just say, for example, I have and I know, Mark, you're doing the water wells data set. So I'll use that as an example. Let's see, let's grab my annotator here. So useful graph, I think that would be useful, is you're gonna have 3 bars. And some people prefer grouped bars, some people prefer stacked bars. I'm more of a stacked bars person just because, and you'll sort of see why. So you're gonna have like a bar, oops, that's not what I meant to do. You're gonna have a bar per class. And let's just say, I know one of the columns with a lot of categories per column is the, I think there's one that says like the manager of each well. So what you would do is, I think of value counts per class. So this would be your, let's see if I can, this will be your 0 class, your 1 class, and your 2 class. And then just based on that, within each bar, you can find the proportion of the bar that is a specific manager. So let's say we have just as a quick example, if we have red managers. So let's say all the 0 classes have like this much in red managers, the 1 class has like this much, maybe the 2 class has like this much. I think it's a good idea to also normalize your value counts, just so that all the bars will have the same size and you can really compare the proportion. But then basically what you'll end up is with maybe something that looks like this. Is probably not going to look as clean, because you for some columns you have like a lot of unique values, but yeah, you'll end up with something that looks like this. And with this, you can really see that, all right, between the different classes, is there like any class that has something different? Like for example, with this example I drew, the 1 class has like very little like green managers is the example I used. And so you can discern the differences between each category. And this, I think, is a neat way of doing it if you have a lot of different categorical variables. If you really have so many categorical variables that this graph is not useful, one thing you can do is just take like the top, maybe like their top 5 or 10, and then just graph those, because the rest would probably be like, if you have one that has like, you know, just 1 instance of the manager per that column, not going to be useful here. So up to you to like pare down the data and just see like for the most occurring managers is the example that I used. Yeah, you can see if the distribution is different across the different classes. I think this is a pretty neat graph. The other one I was talking about would be like grouped bars, and group bars is pretty much the same information, but instead of looking like that, it looks like this. And let me just draw some different colors. It would look something like that per each class. So this is something that, if you prefer, you can consider this. I would say for like, if you decide to do a stacked bar chart, definitely normalize it such that it's all like a proportion rather than the exact values. Nice. Let me just screenshot this and paste this back here. There we go. Any other questions? The one thing that I was going to mention that I forgot earlier, a lot of your notebooks are getting really, really long, which is a good thing, because that means there's a lot of code in there and a lot of stuff for me to look through later on. Definitely consider, if you haven't yet, do the Jupyter Notebook extensions. With the extensions and the specific one, this is something I sent out earlier. I'll send it out again later. Something that would be really helpful is the table of contents. And with a table of contents, one, you can have it automatically number your sections or not. This is actually a setting you can turn on and off. But anything in a markdown cell with like a big sized header will automatically be a section here. So instead of like scrolling up and down and trying to look for the specific like function that you defined, you can literally just like click on this section and it'll automatically jump there. So I think if your notebooks are getting long and you don't have this yet, I really do recommend this. It works with Jupyter Lab as well, in case anyone uses Jupyter Lab. So yeah, this will be a good thing for navigating your notebook for sure. Other extensions, I personally don't use too many because I just like typing, so I don't use a lot of them. This has autocomplete. There's also a variable tracker, so you can actually like track all of your variables. Might be useful if you have a lot of like, if you're saving a lot of different data frames, it'll be something that might be useful for you, so you can like find all the things that you're defining. So yeah, highly recommend Jupyter Notebook extensions. It's really just like a pip install line, I think, in your terminal. Let me see where it says. Yeah, you literally just have to run this in your command line, in your git bash or in your terminal, and it'll be there. This extra tab will show up when you open Jupyter. But yes, any other questions as of now?
Excuse me, Ish. I'm still a little bit hazy about misclassified data. Can you explain about it a little bit more?
Yeah, absolutely. So misclassified data is basically anything that was classified wrong by your model. So in let me just pull up an example of a confusion matrix. let's just see if they probably have examples here. All right, so confusion matrix, misclassified data is basically anything that isn't on the main diagonal. Or again, like some people do their confusion matrices differently, but anything that doesn't have a matching true and predicted label. With your misclassified data, there's a lot of reasons for misclassified data. If you're using one of the more like comprehensive models, by that what I mean, if you're using something like an ensemble method that really accounts for, like boosting accounts for outliers a little better. If you have an ensemble method, it combats your overfitting. So if you are using one of those models, your misclassified data is likely just because the model hasn't been able to separate it properly. And those are likely to be like really weird outliers. And there's usually not a pattern that you can discern here. So for example, like, why are all of these versicolor, I think this is the irises. Yeah, why are all these versicolor irises classified as virginica? So with misclassified data, there's a lot of things that you can do with it. Again, it really depends on how well and how familiar you are with the context of your data. So if I was like a flower expert here, I would be able to go and take a look at these 6 points, and maybe like just based on their data, maybe I could say like, all right, yeah, based on these measurements of like the petal width and sepal width, it makes sense that it's misclassified as virginica. Because I myself, looking at these numbers, would have also guessed that it's a virginica. So it's not something that I can like say that my model was incorrect in doing. Other things you could do, you could literally like take these 6 data points, plot them in like a histogram or something, plot them in relation to either like the versicolors or the virginica to see that, oh wait, it does actually look more similar to the virginicas and the versicolors. Just to say that, all right, yeah, it's not the model's fault that it got these wrong, because these are really like ambiguous data points. So that's something you can do. But yeah, again, it really does depend on like how much contextual knowledge you have here. That's really like a limitation on like how much you can do with your misclassified data. Let's see, what else about misclassified data? Yeah, if you happen to have a lot of misclassified data, sometimes you can run, again, you can probably run like your scatter plot or something to see if there's like a common pattern behind these misclassified data points. You can also extract, like, let's say if it was not just 6 here, but let's say that maybe there were some, let's just put another number somewhere. Let's just say like there's a 6 here, but there's also like a 7 here. Maybe look and see, like, you can really look at these groups separately. All you have to do is like take your Y predictions and your Y and your actual Ys and just concatenate to put them together with your X test. So let's say if this is our test data. I actually just did this for a couple one-on-ones. Let's say you have, this is your X test that you fed into your data frame. All you have to do is just add these back as columns. So here you would have your Y test, and then you'll have your Y predictions. So you'll have your full data frame here. Your predictions and your Y test will all be in the same order as your X test, so you don't have to worry about that. You can really just like put them together like you're creating new columns in a data frame. And then all you have to do is just filter this data frame, like do literally like a dot loc and see like which ones don't have matching values here. So in this example, let's see, here we have Setosa. It was supposed to be Setosa. So the actual value here was 0, but the predicted value was 2. Anything that wasn't misclassified would have the same number for both these columns. So that's how you can get your misclassified data points. And then just do a little, like a really quick analysis on that. I will say looking at misclassified data is something that's more of a level up for this project. I would like leave it till the end when you're like done with your initial modeling process before you get into like looking at misclassified data. Because it's usually pretty hard to come up with conclusions by looking at misclassified data because of the lack of contextual knowledge. But yeah, again, very, very data set dependent. So all you have to do is just pull out like any ones that don't match. And again, you can just do that by pandas filtering, and then maybe do a really quick analysis in those. Any other questions on misclassified data? Nice. So yeah, again, the level of analysis that you do on misclassified data really depends on how well you know your data set. And I know not everyone's doing something that they're very, very well versed in, which is absolutely okay. So yeah, just keep that in mind. This is not something that I'm expecting to see in all projects. All right. Let's see if there's anything else here. Yeah, I'll write some spiel here and here as well. Let's see. If any questions come up, please let me know. I did have another thing that popped into my head that I also momentarily forgot again.
I have a question.
Mm-hmm.
Yesterday I tried to do like an Anova calculation because we had talked about that for the categorical variables. And so I went back to the Anova lab and I really couldn't get it to run. It looked like, I mean, you did like an OLS, an ordinary squares, with the stats models, and you built the formula, and it was just giving me an error. I think about having the binary data. The error was something about the shape of the data. So I don't know if you have time, if we could go over Anova, that would be great.
Yeah, okay, let me pull up, let me see if I have the code here. So these are my Anova slides, and I know that the code actually exists in here. So to run an Anova analysis, this is looking between, and again, there's not too much context. Oh, I do have the data set here. All right, so this is just looking at, this is tooth growth. And this is how much the tooth grew, length. And this is different supplements. You have, I think, VC and OJ, and also different doses. So the purpose of this Anova analysis is looking to see whether with different supplements and different dosages, is your tooth growth length different? For this project, for this example, tooth growth is continuous, but for yours, you can actually put a categorical variable there as well. And but you have to make sure it's numerical. And so what you look at is the main thing that I think, I'm not sure, Melody, if you did this, is you do have to wrap it around with the C if you want it to recognize like the different categories. And so as you can see here, this code, I know they don't do anything to this data set. They actually feed it in just like this. And then basically, because it has like the C wrapped around supplement and dose, it automatically looks for the unique values and then splits them up based on the unique values. So I'm not sure if you did it that way versus, I think if you had already done a one-hot encoding, that might be causing issues because unfortunately, this is not scikit-learn. So you might have to like go backwards and undo your one-hot encoding and do this again. So yeah, then from your Anova, you'll see like within the different supplement amounts, if this is the p-value of the f-score. So if this number is below 0.05, then you can safely say that they're pretty different. And if it's greater, then they're very similar. And they'll do this for each column that you have. So I don't know, Melody, if you had tried this particular syntax with the C's.
Yeah, I just pulled it up. I do have the C's, and
Okay.
It is before the one-hot encoding. But so where you have the formula, I also put a C around the arrest flag since that was my target variable. Should I not have a C like around length in this one?
That's a good question. Try it without the C. Try
Yeah.
it without the C. Yeah. I'm not too sure. I personally, honestly, not as familiar with stats models, but yeah, try that without the C because I'm not sure if it supports categorical dependent variable because this is technically an OLS. But the results should be fine because is your target a binary variable?
Yes.
Okay, then it should be fine. I think you might run into issues if it wasn't binary, but yes.
Okay, if I continue to get an error, I'll just send it over to you or something.
Yeah, please do. Please do.
Can you go over the interpretation of that again? What does that
Absolutely.
mean? Those are both like below 0.005.
Yeah, that's right. So an ANOVA test, if we don't, I'm glad that we have the slides here, but basically it looks at the group means with regards to a single variable. So what you're doing is you're trying to see if there is a significant difference between the groups. So let's say your target, and I know Mark, for your water wells, let's say you have like, I don't know, a variable like temperature. So you want to see if the mean temperature is significantly different between your 3 groups of wells. And then the ANOVA test will be able to tell you that. And ANOVA actually uses an F-score, and an F-score is sort of like think of like a multiple T statistic. That may or may not help with understanding, but ANOVA is very, very similar to doing just multiple T tests over and over again. I mean, not over and over again, but like with, what's the word? Like you're pairing each variable and you're doing a T test within each of those pairs. Because T tests, you only do it for 2 samples. So yeah, it's like doing many T tests. And basically the hypothesis when you do an ANOVA test is by default that there is no difference in the means. And if your p-value is low, below 0.05, there is a difference in your means. So with these 2 variables of supplement and dose, having low p-values with respect to tooth growth length, basically what you're saying is that with different supplements, and in this case it was the VC and the OJ, between VC and OJ, there is a significant difference in the amount of tooth growth by using the 2 different supplements. And same with the dosages. So here you have your dose, and I think there's like a couple different, let's see, there's like 0.5, 1.0, and 2.0. Yeah, so across the 3 different values of dosages, you also have a significant difference of tooth growth with different doses. I don't know, did that help? So basically, low p-value means that they are different. And with that and how it connects to your classification problem, the lower the p-value, the more likely, again, it's not a definite because this is only comparing group means and standard deviations. It is there's a higher likelihood that that supplement and dose will be better classifying features for your model. And then if you have something that has a higher p-value, which goes to say that there is no really big difference between using the different supplements, for example, then having supplement in your classification model is not likely to help. So again, if you were to plot your important features, very likely the ones that have low p-values will be more important, and higher p-values will be less important.
So I was doing this trying to identify what might be a confounding variable. So what would that look like?
Yeah, a confounding variable actually will have a very, very low p-value. A confounding variable, and especially if you have everything categorical, confounding variable can be very easy to figure out. So confounding variable made up of 2 things. One, a confounding variable by definition is if the variable is a result of your target. And I think I talked a little bit about this yesterday, but if you can get, let's say like, I don't know, length of sentence, because yours is, I think, arrest flag. And if like length of sentence is a variable that you have in your data set, which is a direct consequence of, whether arrest flag is yes or no, then that would already be a confounding variable, even though it's not like very correlated. That's one side of it. And the other side would be if there's a perfect correlation. So if it's categorical variables, it's actually very, very easy to check. If you like literally, actually, honestly, you can use the code for, you shouldn't do this, but you can get this information from like, if you plug into like your confusion matrix code, if you plug in like your target variable and your, and one of your features, and if they have a perfect, what's the word? Like, for example, if every 0 in your feature leads to a 0 in your target, and every 1 in your feature leads to a 1 in your target, you have a perfectly predicting, basically that variable is a perfect predictor. And using that confusion matrix method would actually work perfectly for that scenario, because every 0 would match and every 1 would match. That might be a simpler way than doing something like this. But this will also give you information on like how, So if you have a confounding variable or like a perfectly correlated perfect predictor here, you would get a very, very low p-value. Again, I'm not too sure, because again, it comes into, you have to think about like the calculation of these f-scores. So because of that, I personally can't tell you like how low it would be, but lower p-value would make sense if it's a perfect predictor. Or you can try that confusion matrix method. I don't know if that made sense to everyone. Please ask for clarification if needed. But yeah, typically perfect predictors, if you have a variable that is a perfect predictor, you have some pros and cons there. Pro is that it's a perfect predictor. So then like, if every time you see a 0 in this feature, it leads to like a prediction in one way. And then if you see a 1, it leads to prediction another way. That's always good. But most models will tend to overfit to that feature. Not most models. A decision tree or like a naive Bayes, logistic regression, I think will all do that. If you use an ensemble method that like random forest, actually, honestly, I think the boosting methods might also be affected by perfect predictors. But random forest, just because it only looks at a specific subset of features and doesn't always consider the best features, you might be able to get around that. So if you do have perfect predictors, I do think random forest would be a better, like less prone to overfitting model. But yeah, that was an interesting thing to think about. Let's see. Anything else so far? I'm gonna look up and down these guidelines to see if there's anything I wanted to mention.
Ish, I know you've talked about like one-hot encoding in dummies like 800 times, but do you have to, if you have like a multi-class problem, do you have to one-hot encode your target variable?
You do not have to.
Okay.
I know specifically for, if you want to do an ROC curve, you actually might need to do that.
Okay.
But I don't think you have to do an ROC curve. But I think you have to do that for an ROC curve.
Okay.
Yeah, that's a good one. Something that might be of interest to you all. I thought about this because we have been talking about like class imbalance and like the separability of data. So quick way to visualize separability of your data. Separability of data is actually this method that's very similar to PCA. So imagine like all of your data sets have a lot of columns, right? Like I think most of you are working with like an average of like 30, 40 columns, like before or after one hot encoding, which is a lot. And it's very hard to visualize that all at once. PCA is a method of dimensionality reduction. So technically what you can do is use PCA, lower your dimensionality down to 2D, and then you can plot your different variables and you'll get like blobs very similar to a lot of the data sets that we've seen. So I know in like the decision trees, if you lower your dimensionality to 2, you can get a diagram that looks something like this, and then your different colored dots will represent your different color classes. PCA is an algorithm, and we'll get into this more. And again, if like this doesn't make any sense, you don't worry about it at all. PCA, when it does the dimensionality reduction, it tries to maximize variance of your data. So that means when you do your dimensionality reduction with PCA, your blobs of your classes are going to look very overlapping. I can actually show you all an example because I only found out about this after I did this project. And so these graphs actually represent my data in 2 dimensions. So what I did here was I put my data through PCA. And again, I have that 20-minute video if you want to look at it. I put my data through PCA to just visualize what my data would look like if I smushed all my columns down into 2 dimensions. And you can start to see here, it's kind of overlapping, but there's kind of like a pattern of like the blues are on top of the reds. What it means, not much, just because like these dimensions are just a combination of all the dimensions, but it's just a good way to visualize the separability of your data. Why I'm introducing something else is that I did this using PCA. There's another dimensionality reduction technique, not good for classification. So if you want to classify, doesn't make sense to do that. Or maybe it does. I'll take that back. I'll have to think about it a little bit. But there's another method called TSNE or TSNE. And I think it's in scikit-learn here. Yeah, let me put this documentation there. But it does something very similar. What TSNE does is it lowers your dimensionality, but instead of trying to maximize the variance of your data, it maximizes the separability of your classes. So when you feed in your TSNE, and let's just see a couple examples. I don't know how helpful this will be, but yeah, if you have data that looks like this in 3D and all of your data is in like 10 plus dimensions, you can flatten it out, and TSNE will basically try to flatten it in a way that your classes will be as separated as possible. So that's something to consider if you want to visualize what your blobs look like in like smushed down dimension space. That could be something interesting. And the syntax for this, exactly the same as, not exactly the same, but very similar to what you were doing before. So you can see, whoa, what's this? No, this is not what I wanted to look at. But yeah, you can do your dot fit transform. And once you do your dot fit transform, you can plot that graph there. This is really like for a very, very high level EDA, because you don't really get much information about, you know, your features. But if you just want to see like overall, how separable does my data look like if I were to smush all of my dimensions down into 2D or 3D, you can see here, I think I actually do have a 3D version. This is what the 3D version looks like. That's something that you can consider. It's not going to add very much value to your EDA, I'll be honest, but if you just want to have more graphs, and it's, I don't know, it's just like a cool visual to see all of your blobs in like lower dimensional space. Any questions about this? I won't get into like what it means. It's actually pretty easy. I know there are quite a few like Medium articles written about both PCA and TSNE. If you just do a really quick Medium search, you'll be able to find some good like articles explaining what's going on there. But yeah, that's a good one to do. And then all you have to do is just put in a scatter plot. And you can do it in 2D or 3D. Anything else? Just wanted to check if anyone had anything else written here. Yeah, any other questions? Well, cool. I know that within this class, a lot of people are at very different parts of the project. One thing that I have noticed is that for the people who've like, you know, really gotten into the modeling process really doesn't take very long. So for those of you who feel like you're a little behind and haven't like gotten started with the models yet, I wouldn't worry too much, because really like modeling is just like plug and play. And if you take a look at the rubric for this project, passing the project is not super hard. Once you run a bunch of models and like pick one and interpret it a little bit, that works. But the value add is really in how rooted into context your entire project is. If you keep considering like your business case that you've set up, that's going to be what's valuable. Because again, like the role of a data scientist in most places is turning, you know, technical insights into non-technical insights, coming up with like actionable things to do based on what it is that you're doing, all these technical things that you're doing. All right, any final questions to wrap up?
I'll ask another one. Would it make sense for my data, being that it's related to date, is sort of in a chronological order, but I've got a very large data set. Would it make sense to divide it into, look at the first couple of years and look at the current couple of years and compare how the models look different to see if anything has changed?
For sure. Yeah, you can definitely do that. Like one method of doing, especially if you have temporal data, so any data that has time as a feature, typically what is recommended is to not use time as a feature. At least like not like time as one column. If you separate it into like days of the week or month or like time of day, that's fine as like dummy variables, that's okay. But with temporal data, one very common way of cross-validating is actually splitting up, yeah, like what you're mentioning, like maybe for cross-validation, instead of doing it on random subsets, you would do it on like a specific period of time. So I'm not sure how long the data set, like for example, if your data set spans 2 years, maybe do like half a year, half a year, half a year, half a year, to just see if, you know, your model fits differently or if it loses predictive power at different subsets of your data. That's actually something that's very important, especially when you have a model in production, because obviously, as you know, the world keeps changing, and therefore models that are in place now might not work in the future. So that's actually something that's very commonly done with any models that are put into production. You want to test to make sure that it's still, what's the word, reliable? Is that the word I'm thinking of? Yeah, that it's still reliable and it's still, you know, fit on, yeah, just that it's more reliable and it is adapting to changes. Because for example, in a lot of industries, models that were fit on pre-coronavirus data might not work for post-coronavirus data. So it's just good to like check for temporal changes. Yeah, you can definitely split your data based on time period.
Yeah, I was thinking I was wondering if I could like draw conclusions that something has changed if the model was good at predicting in the early years, but it's not good now. But then again, 2020 has been such a crazy year that I'm not sure any data from this year is valid for anything.
Oh yeah, yeah, that's actually a very that's a very real problem. I do work, I don't know, I forget if I've told you all, but I like do contract work on the side sometimes, and I've been like writing like machine learning, like recommendation algorithms for an app, and like the data that they've collected before is so different from the data that they have now, and so therefore I had to like do a whole overhaul of how like the model's being built. So yeah, very, very real problem. I can't believe, like, yeah, I never really think of it in like when I'm teaching this stuff, but yeah, that's a very real problem and like cool to think about. We will get to this kind of stuff when we get to time series a little more. And there are, yeah, and you basically see that it's very, very common for models to lose predictive power as time goes on, especially if time is a factor. Cool. That was an awesome question. Made me think a little. Anything else? We do have about 10 minutes left. Any other questions? Cool. If there's nothing else, as usual, feel free to Slack me with any other questions that you might have. I think it would be very beneficial to like Slack the questions that you have into your respective, either in the class channel or in your respective like data set channels. I think it'd be cool. And I'm sure a lot of people working your data set will, one, be able to help you, or two, have the same issues that you can work through together. I will be looking into that string IO thing right after this. So yeah, look out for any updates from me. And yeah, keep the questions coming on the doc. I think these are really good to drive like discussion during these office hours. Right, if there are no final questions, going once, going twice, I will see you all tomorrow at office hours again or at your respective one-on-ones. All right, have a good rest of your day, everybody. Bye.
Thank you.